I want you to take a walk with me, right now, in your head, and I promise it ends somewhere strange. You're standing at the very top of the world, the North Pole, snow in every direction, and every direction you look is south, because up there nowhere is left that isn't. Now set off walking, dead straight, no turning, no wavering, straight as a dropped plumb line, down the face of the globe until your boots hit the equator. Stop. Turn one square corner to your left, a clean quarter turn, no more. Walk straight along the equator a good long way, whistling to yourself. Stop again. Turn one more square corner, the same way as before, and walk straight home. And here's the thing that keeps me awake at night. You arrive back exactly where you started, at the pole, and you have walked a triangle with 3 square corners in it. 3. Try to draw that triangle on a flat sheet of paper, and you cannot. You are not allowed. The page hasn't got the room for it. So who handed you the extra corner? Nobody stepped off the earth to bend it into shape. You never left the ground. The ground did it, all by itself, while you weren't looking.
The ground did it while you weren't looking. Yes, and I want to sit right on that word, looking, because it's the whole night. You did not climb up above the earth and peer down at it, round and blue, and go, "Ah, a ball. Of course my triangle bulged." You never once got outside. You walked the thing with your nose a few feet off the snow, and the snow told you, in a language of corners, that your world is not flat.
The snow told me. In corners.
In corners. The surface confessed its own shape to a creature crawling around on top of it, and it never once had to lift that creature up for the view from above. That is the thing I mean to teach you tonight. That a surface can tell you what shape it is, from the inside, without your ever stepping off it. Nail it down, and the most frightening word in this whole course stops being frightening at all. And I'll tell you a secret. It's the word the whole course has been sneaking up on from the first night. The box you couldn't tell from a rocket. The diving board where gravity switched off for one clean heartbeat. The 2 apples last week that wouldn't fall parallel. Every one of those was a step up the hill toward this one word, and tonight we finally say it properly.
Which frightening word? I've collected several of you these past weeks.
The one you've been flinching at since last week. Curved. I stood here and told you space-time bends, that gravity isn't a force, it's the shape of the thing we live inside. And I watched your face do a particular thing.
You did watch my face do a thing, because you left me with a question, and then, in your usual style, sent me off up the hill to stew on it for a week. May I say the question out loud? I've been carrying it around like a stone in my shoe.
Say the question. That's what it's for.
Curved into what? That's the question. You keep saying the universe is curved, space-time is curved, the fabric bends. And every single time, some stubborn little animal at the back of my skull puts its hand up and says, "Hang on, curved needs somewhere to curve into." A sheet of paper curves into the room. A road curves across the countryside. When a thing bends, it bends into the space around it.
Go on, land it.
So when you tell me space itself is bending, where's the room for it to bend into? Is there some bigger space, a great empty extra dimension that our whole universe is draped inside of, sagging like a hammock? And if there is, what's out there in that room? And if there isn't, then curved is just a word you're waving at me with nothing behind it.
There it is. And I want you to know that is not a foolish worry. It's the single best question you could bring to this. It's the question that stops most people cold. It stopped the finest minds cold for a good while too. Because you're right about the paper and right about the road. Everything you've ever seen bend in your life bent into some surrounding room. So the demand feels ironclad. Show me the room.
Show me the room, yes. Where's the fourth dimension our universe is sagging into?
And my answer, the answer this whole night is built to make you believe in your bones, is that there is no room. There needn't be one. The curvature is real, it's measurable. You can catch it red-handed with a tape measure and your own 2 feet. And it needs no bigger space to bend into. No outside. No fourth dimension holding it up. None of it. The bending is a thing the fabric owns entirely on its own account, as much its own as its length or its breadth, and it has not the faintest thing to do with any room it might or might not be sitting inside. I know exactly how that lands. It lands like a flat contradiction. So I'm not going to argue you into it with clever words. I'm going to build it in front of you, out of nothing but an ant and a tape measure, and let you watch it happen until you can't help but believe.
Now you've made the stone in my shoe worse, not better, because that sentence is a lovely bit of poetry and complete nonsense in equal measure. Curved, with no room to curve into. That's like telling me something's moving but there's nowhere it's going.
It sounds that way. It isn't, because there are 2 completely different things we've both been lazily calling by the one word, curved, and they've been hiding inside each other your whole life. One of them does need an outside room. The other, the one that matters, the one gravity is made of, does not.
2 different curveds. All right, how do you pry them apart?
I shrink you down and put you on a surface you can never leave. So, let me make you small.
I had a feeling this was coming.
Picture an ant. A clever ant. A little surveyor with a tape measure and an endless roll of chalk and all the patience in the world. And this ant lives on a surface, and the cruel condition of its whole existence is that it can never get off it. It can't hop. It can't fly. It cannot lift its head up out of the surface and look down and see the shape of the thing it walks on. Because up, out of the surface, is a direction that, for the ant, simply does not exist.
No up, poor thing. So everything it'll ever learn.
Everything it will ever know, it finds out by crawling and measuring. Distances, angles, corners. That's the whole toolkit. Are you with the ant?
I'm the ant. Flat cap, tiny tape measure, no way out. Go on.
First surface. I take a big flat sheet of paper, lay it on the table, set the ant down, and the ant gets to work. It draws triangles, and every triangle's 3 corners add up to a straight line's worth, always, big or small. It draws 2 lines that start side by side, marching the same way, and they stay side by side forever, never drifting together or apart. It draws a circle and measures the rim, and the rim always comes out the tidy length it ought to. Every measurement says one calm word.
Flat.
Flat. Its world is flat. Its geometry is the flat geometry you learned as a child, and all is well.
Fine. Flat paper, flat answers. The ant's a bit bored, honestly.
The ant's a bit bored, so let's liven things up. While it's asleep, I pick up that same sheet and I roll it. Curl it round into a tube, a perfect cylinder, like a rolled-up poster. Now, to you and me, standing outside and looking down, that paper is obviously, visibly curved. It's bent right round into a tube. Agreed?
Plainly, it's a tube, about as curved as a thing gets.
So the ant wakes up and redoes every measurement it ever made. Every triangle, every pair of lines, every circle. And tell me, what does it find has changed?
Everything, surely. The world's a tube now. Its triangles must go funny. Its lines must...
Nothing changes. Not one measurement. Not a hair.
Nothing.
Nothing at all. Every triangle's corners still add to a straight line's worth. Every pair of parallel lines stays perfectly parallel. Every circle has precisely the rim it always had. The ant, crawling about with its tape, cannot find the faintest sign that anything has happened to its world. As far as anything it can measure from the inside is concerned, its world is still dead flat.
But that's mad. I can see the tube. You can see the tube. It's right there, curved as anything.
We can see it because we are cheating. We are outside it. We're floating in the room the paper sits in, watching how the paper sits in that room. From out here, yes, it bends. But that bending lives entirely in the relationship between the paper and the room around it. It does not live in the paper.
Why not? Bent is bent.
Because when I rolled that sheet, I never stretched it, never tore it, never crumpled it, never squashed one part nearer another. Every ant-sized distance on that paper is precisely what it was when the sheet lay flat. I only bent it through the outside room. And the ant doesn't live in the outside room, it lives in the paper. So it feels nothing.
Huh. So the tube is curved on the outside, but flat on the inside. Curved to us, flat to the ant.
You've got it. And that first kind, the tube kind, the kind you can only see from outside, the kind that's really about how a thing is draped in some bigger room, call it the shallow kind of curved. It's real enough, but it's a fact about the room, not about the surface. And here's the punch. That shallow, from outside kind is precisely the kind you were demanding I show you a room for. Curved into what? You were asking me to show you the tube's room.
And for the tube, there honestly is one.
For the tube, fair enough, there is. But space-time isn't the tube kind. So let me give the ant the other kind. Put the tube away. Take the ant off the flat paper altogether and set it down on the surface of a ball. An orange, a globe. And now watch what the little surveyor finds.
Now the triangles misbehave.
Now everything misbehaves, and gorgeously. The ant draws a big triangle, and the three corners come out to more than a straight line's worth. There's a surplus, extra corner out of nowhere. It draws two lines, starting off perfectly parallel, each dead straight, neither one ever steering, and it watches them, against all its flat world sense, lean toward each other and cross. It draws a circle, walks out its paces, joins the rim, and the rim comes up short. Less edge than there ought to be, for how far it walked.
And there's no clever roll of the paper that fakes any of that.
None, because you cannot roll a flat sheet onto a ball. Try it. The paper fights you. It crumples, it puckers, it tears, it bunches at the poles. The world's map makers have wrestled that exact fight for centuries. You cannot flatten the round Earth onto a flat page without lying somewhere, stretching something, ripping something.
My flight maps. The ones where Greenland's the size of Africa.
Your flight maps. And that stubborn refusal of the flat and the round to lie down onto each other without damage is not the map maker's clumsiness. It's the fingerprint of the real thing. The ball is curved in a way the tube is not. Curved on the inside. Curved in a way the trapped ant can measure without ever leaving home.
So there really are two different curves. The tube's, skin deep, needs an outside room to even mean anything. And the ball's, what, baked into the surface itself?
Baked in. Woven through. It's about how the distances inside the surface actually sit together. Whether the surface, in its own private accounting, is laid flat or bunched round. And the liberating, slightly dizzying fact is, the ball's kind, the deep kind, the real kind, the ant measures every scrap of it from the inside, and it never once needs to ask your question. Curved into what? Doesn't even come up. The curvature was never about an outside.
So when I stood here panicking about the fourth dimension the universe is sagging into, I was demanding the tube, asking you to show me the room for a thing that's the ball kind, that never had a room and never needed one.
You are asking me to show you the outside of a thing that hasn't got one, and doesn't miss it. There may be some grander space our universe sits inside. There may not be. And here's what took my own breath away when I first met it. It doesn't matter even slightly. It changes nothing anyone can measure. The curvature of our world is the bull's kind, the honest kind, entirely a fact about the fabric itself.
That's a genuine weight off. I've been lugging that fourth dimension about like a rucksack full of bricks. You're telling me I can just set it down.
Set it down. Leave it on the path. You won't need it once tonight.
All right, but before I trust you completely, did somebody actually have to discover this? That a surface knows its own shape without help? Because it doesn't feel like the sort of thing that's obvious.
Somebody did, and it's one of the great quiet turns in all of mathematics. There was a man, a surveyor himself, among the greatest who ever lived, forever out in the fields with instruments, measuring the real curved land of the real round earth, and he was the first to prove the thing whole, that the deep curvature of a surface lives entirely within the surface, that a being trapped inside could compute it, every last bit, from measurements made at home. He was so pleased he gave it a grand Latin nickname, something like the remarkable theorem, and for once the grandeur was earned. His name was Gauss. That's the one name I'll hang on tonight, and then I'll let him go, because the idea's the thing, not the man.
The remarkable theorem. He was pleased with himself.
He'd earned a little pleasure. Now, I've had the ant-catching curvature 3 ways, and I've been waving my hands at all 3. Let's actually do them, because each one comes back and matters. Start with the one you walked in the door with, your triangle, the 3 square corners.
My sleepless triangle. Take it apart. Why is 3 corners impossible on the flat page, but fine on the ball?
Flat page first, so the baseline's nailed down. On a flat sheet, take any triangle you like, thin, fat, huge, tiny, and add up its 3 corners. The turning at the 3 corners, all told, always comes to the same thing. A straight line's worth, a half turn. No more, no less, ever.
The iron flat law. Fine.
So think what that budget allows you. Spend a square corner here, another square corner there, 2 square corners, and you've spent the entire allowance. A straight line's worth, gone, which means your 3rd corner must be nothing at all. A dead straight non-corner. You physically cannot fit 2 proper square corners into a flat triangle and still have anything left to close it up.
Right. 2 right angles, and the triangle's already got no room to shut. The 3rd side just runs off parallel forever and never meets. No triangle.
No triangle. So go back up to the pole and count what you actually did. A square corner down at the equator. Another square corner further along the equator. That's 2, the whole flat budget spent. And then you turned a 3rd square corner and walked home, and the triangle closed anyway.
I got a 3rd square corner for free.
For free! A whole quarter turn of corner more than any flat page in the universe would ever hand you. And that surplus, the corner you got for nothing, that is the curvature. That's it. That's the whole thing, caught in a jar. The amount your triangle's corners overrun the flat budget is a direct, honest measurement of how curved the surface is inside the triangle.
And a bigger triangle overruns more?
Bigger triangle, bigger overrun. Draw a tiny one on the ball, small enough the ball looks nearly flat around it, and the overrun shrinks toward nothing. That's the surface whispering, around here, up close, I'm almost flat. The ant never needs a photograph of the globe. It draws triangles, counts the overrun, and the overrun tells it everything.
So the corners of a triangle are a curvature meter. That's actually usable. I could survey a whole country, and if my triangles kept running over budget, I'd know my land was round, even if I'd never once seen it from above.
People have done precisely that. Measured enormous triangles across the real countryside, corner by patient corner, and watched the numbers run just slightly over the flat budget. And there, in the overspill, was the roundness of the earth, dug out of the dirt by surveyors who never left it.
The ground can't keep its own secret. Draw a big enough triangle and it blurts.
It blurts. Now the second way, and this one I want you to hold especially close, because it reaches straight back to last week and grabs the thing we couldn't let go of. Two parallel lines. On the flat page, you said it yourself, start two lines side by side, pointing the same way, each dead straight, and they stay side by side to the ends of the earth.
Never meet. That's practically the definition. You could set your watch by it.
So set the two ants going. Two of them, down on the equator, a little way apart, and I line them up with enormous care. Both facing due north, both pointing precisely the same direction, both setting off perfectly parallel. And I give each the one strict order. Walk dead straight. Never turn, never steer. Don't lean toward your friend, don't lean away. Just go relentlessly straight ahead. Off they march, north, straight as string, never once turning the wheel. What happens?
Well, they set off parallel, and each has promised never to turn, so they ought to stay the same distance apart the whole way up. That's what parallel and never turning is supposed to buy me.
They collide. At the pole. Two ants who started side by side, who each swore never to turn, who each kept that promise faultlessly the whole way, run straight into one another at the top of the world. The gap between them closes, and at the pole there's nothing left of it at all.
But neither of them turned. You said they never turned.
Neither of them turned. Cross my heart. Each ant, feeling along its own path, going straight ahead every step, would swear on anything you like it never once steered toward the other. And yet the gap shut. They did not move toward each other. The world moved them toward each other. The surface itself curved under their feet, folded their two straight paths together, and drove them into one point. And neither ant ever felt itself do a thing but walk straight.
Two things going perfectly straight, drawn together, without either one steering. That's, say it, that's the apples. That's last week.
That's the apples. Last week I stood here and dropped two apples, a little way apart, and let them fall toward the earth. And they did not fall down two parallel lines the way a good flat world says they should. They leaned. They drifted toward each other as they fell, each one falling toward the center of the earth, and the centers of things are places where two lines can meet.
And you told me that lean was the one bit of gravity I could never scrub out.
The one bit. You can jump off the diving board and cancel gravity for a second, float, feel nothing. But you cannot make two apples stop leaning toward each other. The lean survives every trick. And now I'm telling you what the lean is. It's this. The ants on the ball. Two paths that start parallel and are driven together with nobody steering. That is what curvature looks like from the inside.
So the apples don't lean because a force reaches out and tugs them together.
They lean because the world they fall through is curved, and on a curved world, straight paths converge. Last week, I promised you the thing we couldn't erase behaves exactly like parallel lines bending on a curved surface. Tonight I'm cashing it.
Give me a second with that because it genuinely reorganizes something. All my life, the apples fall together because gravity's tugging each of them to the middle, and you've swapped the whole engine out from under it. There's no tug, there's a shape, and the shape steers them, the way the ball steered the ants.
There's a shape, and the shape steers them. Hold that at exactly that temperature, because in a few minutes I'm going to pour the whole of gravity into it. But the ants got one more trick first, and it's the strangest and my favorite. The circle that comes up short.
The one with not enough rim, it's been nagging me. How does a circle have the wrong amount of edge?
Let the ant build one, carefully. It picks a center, say the North Pole, it's handy, and walks outward the same number of paces in every direction, planting a flag at the end of each walk. Every flag the same distance from the pole. That's its honest, walked-out radius, its reach. Then it joins the flags into a rim and measures how long that rim is, all the way round. On the flat page, there's an old rigid bargain between the reach and the rim. Bigger reach, proportionally bigger rim, in lockstep forever.
The good old bargain, reach and rim marching in step. I trust that one deeply.
So the ant does it on the globe, with the pole as centre. Its ring of flags is a ring of latitude, a circle round the top of the world. It measures the rim, and the rim is short, less than the flat bargain swears it should be for how many paces the ant walked out. There's rim missing, and the further out it walks, the closer its flags creep toward the equator, the worse the shortfall gets.
How far can it push that?
Far enough that past a point, walking outward starts making the rim shrink instead of grow.
Walking outward makes the circle smaller? That's the world gone completely round the bend.
It's the world gone literally round the bend. That's just what round does to a circle's books. And the ant needs no globe, no outside eye, no photograph. It walks out its reach, measures its rim, finds the rim come up short against the flat law. And that shortfall is one more clean measurement of the curvature made entirely from within. 3 tools, triangles that overrun, parallels that converge, circles that come up short.
3 independent snitches, every one worked with a tape measure, and no fourth dimension in sight. All right, I'm converted. The curvature's real, it's inside. It needs no room. I've set the rucksack down. So where does this go? Because so far I've a very charming ant and a globe, and you promised me gravity.
I promised you gravity, and to get there I need one more idea. The hinge the whole rest of the course swings on. I've had the ants walking dead straight this whole time, and you've let me get away with it. But think about it. What does straight even mean for a thing stuck on a curved surface? There are no straight lines on a globe. Every path bends, seen from outside. So when I tell the ant, walk straight, what am I actually asking of it?
Yes, there isn't a straight line on an orange, is there? Every line you draw on it is bent. So walk straight is, what, a cheat?
Not a cheat, a promotion. We need a new idea of straight, one the ant can obey from the inside, one that doesn't need a flat world to live in. And here it is, and it's lovely in its plainness. To go straight is to never turn, that's all. Don't steer left, don't steer right. Whatever's under your feet, keep going dead ahead. Take the most forward step available to you, over and over, and never favour one side.
Never turn the wheel, that's the whole of it.
That's the whole of it. And a path walked that way gets its own name. We call it a geodesic. The straightest path a surface will let you walk.
A geodesic, the never-turn path, the straightest available, even where nothing's truly straight.
On the flat page, the never-turn path is just an ordinary straight line, the old kind. So it agrees with everything you already know, nothing's lost. But on the globe, it's something richer. Pull a string tight between 2 points on a globe, tight as it'll go, and the line it snaps into is a geodesic. It's the shortest way across the surface, and it's the straightest, and those turn out to be the same thing.
And on a ball those straightest paths are, you said it earlier,
the great circles. A great circle is any circle on a ball as big around as the ball itself, one whose own centre sits at the centre of the ball. The equator is 1. Every line of longitude, pole to pole, is half of 1. Slice the globe clean through its middle, and the rim of the cut is a great circle. Those, the biggest circles the ball's got, are its straight lines, its geodesics.
So when the 2 ants walked dead north and never turned,
They were each walking a line of longitude, a great circle, a geodesic. That's why they collided. All the lines of longitude, every straight ahead, heading north, come together at the pole. The straight paths of a globe meet.
So straight and shortest and great circle and geodesic are all four the same animal in different collars.
All four the same animal. And now I can hand you a thing you've puzzled over your whole life without knowing it was this. The path a long-haul flight takes, drawn on a flat map, a flight going a long way east and a long way north, doesn't run in a nice straight line across the map. It arcs, bows up toward the pole, like the planes taking a scenic detour up over the top of the world for no reason.
I have complained about exactly this, sitting there thinking, why are we going up over Greenland? Just point the nose at the destination and fly the straight line. You're wasting my evening.
And the plane is not wasting your evening. The plane is flying the straightest, shortest path there is. The geodesic, the great circle, the taut string pulled tight across the real round Earth. It's the map that's lying, not the plane. To print the round Earth on a flat page, the map had to stretch and tear the truth. And one of its lies is that the genuinely straight path looks bent.
So the bend I'm grumbling at is the map's crime, not the pilot's.
The map's crime. The plane never turned the wheel. It walked the ant straight line. And you, in the window seat, watched a geodesic and called it a detour.
That'll ruin every flight map for me forever, in the best way. But I'm still on a globe, George. Charming as the ant is, I don't live on an orange. Where's the gravity?
Here's the gravity. Take everything. The ant, the never-turning walk, the geodesic, the straight path that looks bent to an outsider. Take all of it, lift it up off the two-dimensional skin of the ball, and set it down in the real thing we live inside. Not space, space-time. The whole fabric, the three directions of space and the one of time, sewn together into the single cloth we've been building since the last course.
And that fabric is curved.
That fabric is curved. The ball's kind of curved, the honest inside kind. And it's curved around anything heavy. The earth, the sun, and things move through it the only way anything ever moves through a curved world. They walk geodesics. They go dead straight. They never turn the wheel.
The moon walks a geodesic.
The moon walks a geodesic. The moon is not on a leash. There is no rope of force running from the earth to the moon, hauling it round and round. The moon is doing the laziest, most unforced thing a body can do. Going perfectly straight, never turning, taking the most forward step available to it, over and over, through a space-time that happens to be curved around the Earth. And a straight path through a curved world, seen from where we sit, looks like a circle. It looks like being swung on a string, but there is no string. There's a straight walk through a bent fabric. That's all an orbit has ever been.
So it's the flight map again. The moon's going straight, and we, standing off to the side, drawing its path, see the straight path come out as a loop, and we invent a force to explain the loop. The way I invented a detour to explain the plane.
That is precisely it, and I couldn't have set it beside the flight map better myself. We watch a thing go straight through curved space-time. We see its straight path come out curved, and for 300 years we called the curve gravity, and imagined a force doing the bending. But the force was our detour. The story we told because we couldn't see the shape the moon was walking on.
Newton's story.
Newton's story, and it's superb. It predicts the loop beautifully. But it's a story about a pull, and there is no pull. There's a shape.
Then do the apple. Don't leave it in orbit. Bring it down here where I dropped it. Because an apple doesn't loop, it falls, straight down, fast. How is falling straight down going straight through a curved world? It looks like the most pulled-on thing there is.
It looks utterly pulled on. And here I have to be careful and honest, because there's a subtlety that's easy to fumble, and I won't fumble it. Toss an apple up and across the kitchen, and it traces an arc through the air. A curve, not a straight line. So how can I call that a geodesic? A straight path.
That's exactly what I want to know. That arc is about as unstraight as it gets.
The arc is not curving through space, it's going straight through space-time. And those are wildly different because the apple isn't only moving across your kitchen, it's moving through time. Every apple, every one of us, is barreling through time, whether we stir a muscle or not.
Moving through time, even sitting still.
Especially sitting still. Now feel this. In the little moment it takes to toss the apple up and catch it, call it a second, how far does the apple travel through space? A stride. Up a bit, over a bit, down. But in that same second, how far did it travel through time?
A second into the future, which I've never once thought of as travel.
It's travel, and it's the bulk of the whole journey. Because a second of time, in the fabric where space and time are cut from one cloth, is not a small stretch. Measured in the same units as the space, the way this course taught us to measure both in 1 second of time is an enormous distance. Vast. So almost the entire journey of that apple isn't the little stride across your kitchen, it's the immense march forward through time.
So the apple barely moves in space and travels a colossal way through time. And the arc I see.
The arc you see is what an almost straight path through space-time looks like once you flatten away the huge time direction and keep only the little bit of space. The apple's true path through the full fabric is very nearly straight, a geodesic, a never-turn walk. But space-time is gently curved near the Earth, and even a slight curvature, working on a path that runs an enormous distance through time, is enough to bend it by the small amount we see as the apples fall.
So the apple falls for exactly the same reason the moon orbits and the ants collide at the pole. Straight walk, bent world, no pull anywhere in it.
No pull anywhere in it. The apple, the moon, a comet, a dropped coin, you stepping off a diving board. Everyone is doing nothing but going straight. The ants straight, the never turn straight, through the one curved fabric. What we spent 3 centuries calling the force of gravity is the look of a straight line in a curved place. Going straight is all it does, and going straight here looks like falling.
I have to sit in the size of that for a moment, because I came up this hill still believing, really believing, underneath everything you've told me, that when I drop a cup, something reaches out and pulls it down. And you've quietly removed the something. There's no hand. The cup falls because the straightest path it can take through a bent world runs it into the floor.
There's no hand. There never was a hand. And here's the thing that gets me still, after all these years. The falling thing feels no pull, because there is none to feel. Step off the board, and for that whole second of falling, you feel nothing. Weightless, at peace, because you are not being pulled. You're following your straight path through the fabric, and nothing is fighting you.
Then when do I ever feel gravity as a force at all? Because I certainly feel something, sitting in this chair.
You feel the chair. That's the trick of it. The only time you ever feel gravity as a force, the press of this chair on you now, the ground shoving up at your feet, is when something stops you from falling. The floor is the only thing doing any pushing in this whole room. The earth's not pulling you down into the seat. The chair is shoving you up, off your geodesic.
The floor is the villain, not gravity, the floor. Every ache in my feet at the end of a day is the ground refusing to let me go straight.
The ground refusing to let you fall. That's the whole inversion of this course, said in one line, and you just said it. And here's a small gift I'll fold in, because you earned it last season, and it belongs right here. Remember the 2 sisters, the one who flew everywhere and the one who stayed home, and how the realest thing either owned was the honest count of hours she actually lived. Her own time ticked along her own path.
The time you actually live. I've not forgotten it. It's the truest thing you ever gave me.
Then take one more step with it. Of all the paths a falling thing could take between here and there, the geodesic, the straight one, the one it actually takes when you let it go and leave it alone, is the path that racks up the most of that honest, lived time. The most hours actually lived. Falling freely, going straight through the fabric, isn't only the laziest path, it's the longest aged one.
The apple, left alone, doesn't just fall. It takes the route through space-time that lives the most.
It takes the route that lives the most. I'll not open that box all the way tonight. It's got a whole evening of its own waiting up the road. But I wanted you to see that the straightest path and the most lived path are the same path. The universe is thrifty and generous in the one gesture.
The straightest path is the one that lives the most. I'll be turning that over the whole walk down. Let me try to say the night back to you. Stop me where I've dropped a stitch. Curved doesn't need an outside. The ant proved it. Tube versus ball, from the inside, tape measure only. The curvature's caught three ways. Triangles overrun, parallels converge, circles come up short. Straight gets promoted to never turn, the geodesic, and the great circles are the globe's straight lines. And gravity's gone, replaced by things going straight through a space-time bent around anything heavy.
Keep going. You're nearly through it.
The moon's not pulled, it's straight. The apple's not pulled, it's straight. My cup's not pulled, it's going straight into the floor, and the floor's the only thing in the room that ever pushed. Nothing's pulled, everything's straight. The world is bent.
You dropped not one stitch. That's the whole cloth, and it's yours now.
Then here's the hole I can see in it, and I suspect you left it there on purpose, the way you always do. This shape, this curvature. You keep saying it's bent around heavy things, more bent near the earth, near the sun. So the bending isn't the same everywhere. It's got a layout, a pattern. This much curved here, that much curved there, flat, far from anything.
Go on, you're building it yourself.
So something has to hold that pattern. Something has to say, at every single point in the whole fabric, exactly how bent it is right there. How much a triangle would overrun if you drew it here, which way straight ahead points from this spot, how hard to steer the apple. Where does all that live? What is the thing that stores the shape?
And there, right there, is next week. And you've walked us to its door without my having to push you. Yes, if curvature is real, and it varies from place to place, then there must be something written into the fabric at every point that holds the local shape, that hands each falling thing its marching orders, that tells every geodesic which way is straight, that tells the ant exactly how much its triangle will bulge here versus there. One object, sitting at every point of space-time, quietly storing the geometry, telling matter how to fall.
And it's got a name, this thing.
It's got a name, and once you have it, you don't just have the shape in words and pictures anymore. You have the actual machinery. The thing you could hand to the universe and say, "Here, this is how you're bent, now go." It's the ruler and the clock of space-time itself, and it can be a different ruler and a different clock at every point, and that variation is the whole of gravity. We call it the metric.
The metric. And you're going to leave it there, aren't you? Right at the door.
I'm going to leave it there, but I'll give you one thing to keep you up the way your triangle did. Down here near the earth, the part of that shape that does nearly all the work, the part that reaches out and drops your cup, isn't the bending of space at all. It's the bending of time.
The bending of time drops the cup, not space.
Not space. And that is where I leave you tonight.
Of course it is. You get right to the edge of the best part, set the teacup down, and send me up the hill. The bending of time does the falling, not the bending of space, and you're not going to say another word about it.
Not another word. Not tonight.
Then I'll carry it up with the rest. I came here frightened of a word, curved, lugging a fourth dimension in a rucksack, certain the universe had to be sagging into some bigger room, or the whole thing was nonsense. And I'm walking down having set the rucksack on the path, because a little ant with a tape measure showed me that a surface can know its own shape from the inside, and gravity turned out to be nothing but things going straight through a fabric that's bent. The moon going straight, the apple going straight, my poor cup going straight into the floor, and the floor the only thing in the room that ever pushed. No hand, no pull, no string, just a shape. And next week you'll finally show me the thing that holds the shape, the metric, the ruler and clock that change from place to place. And tell me the secret you just left dangling, that near the earth it's time that bends and does the falling, not space. I don't yet know what it costs to believe a thing like that, but I can't unsee the ant. Good night, my friend. I'll be down early, and I'll bring my grandmother's flat little triangle down with me so we can see together how much the world overruns it.